Hello, good morning students. On behalf of Vdvs online studies, I am welcoming you, all of you in this new lecture in Standard 9th Science, in which we are studying the Gravitation chapter. But before we going to start our new topic in today's lecture, let us take a brief preview on what we have studied so far in this chapter. Earlier we have started this chapter with the concept regarding the gravity and gravitational force. Whenever two objects came nearby each other, it experiencing some kind of force of attraction between them, and that force of attraction between them is called as a gravitational force. Another thing that we learned after that, on what factor this gravitational force is dependent upon. So that is also we have discussed in the previous lectures. If you haven't seen that lectures, please go and visit that lecture. Okay. Another thing that we have discussed in this chapter, that after any gravitational force acts on an object, so it will be impacted on both the objects. It will dependent on the both objects. But how can we consider that how they will depend on the both the objects? So in that case we'll have to understand about the first law of the gravitation. Okay. Also we have seen on laws regarding the Kepler's law of motion, in which we have seen that the planets or the universe in this universe, the planets are revolving around this sun. So we have seen on motion why they are doing an elliptical motion, and why this elliptical motion is helping us in these discoveries. So that's the topic we have already discussed in the previous lecture. But the law that we have understand for the attraction of the force is what? That the force of attraction or the gravitation force is mainly dependent upon the two things mainly. It is dependent on the masses of their masses of the product of the objects. Okay, and it is also dependent upon the distance between them. Okay, the basic regardation of that concept is what? That when two objects, if they has a much more mass, they will perform and much more, they will act much more force between them. Okay, they will experience a much more force between them. While in the distance, whenever we are increasing the distance, it will not, it will decreases the force of attraction between them also. Okay, so whenever we are increasing the distance, it will decrease the force of attraction between them. Whenever we are decreasing the distance, then it will increases the force of attraction between them. So that is the law that we have seen in the previous lecture. Also, we have derived the SI unit regarding that what is the SI unit of force of attraction between the two objects. In that we have seen the where we have to put the sign of proportional. Whenever we want to remove the sign of proportional, so we'll have to put an is equal to sign. So whenever we are putting an is equal to sign, we'll have to put some kind of constant between them. So that's the constant that we have put in the equation is known as the universal gravitational constant. And in the last lecture we have seen about the free fall. So basically from the law of Newton's second law, that F is equal to m into A. Okay, the second law of motion that we have already seen. F is equal to, we'll take a blue marker. Okay. Now, according to Newton's second law, what he has given us the basic idea. He has given us the basic idea regarding F is equal to m into A. While m is the mass of an object, be the acceleration between them. Okay, that's the thing that we have already discussed in the previous lecture. But in the free fall, whenever we are understanding the free fall concept, now first thing that we have understood in the free fall is whenever we are throwing the two objects, but if they have a less masses according to each other. If one object has a 15 kilogram of mass, while the another object has a 5 kilogram of mass. So according to the Newton's second law, the 15 kgs object will be first touched to the surface of the earth because of the gravity. Okay, and while the 5 kgs will be come after the 50 kilograms object will hit the surface of the earth. Okay, so that is the topic that he has given in the Newton's second law, and also we have understand the free falls concept into that. Okay, now we are going to the deep in this topic, that what happen if we are considering this force of second law of force, and also the law that we have learned in the previous lecture. The law that we have learned in the previous lecture is F proportional to m1 into m2 upon d square. Okay, that is the law that we have understood. F is equal to capital G into m1 into m2 upon d square. Sometime the d will be I have write all the things here. m1 is the mass of object 1. Object 1, and 2 is the mass of object 2. Okay, and d is the distance between them. So these are the things that we have already seen. But see, the distance between them, sometimes they will denote with the r. So don't worry about that. It is the same, D or R, both will be same. Likewise that they have sometimes denoted the M1 and M2 with the small m and capital M. So small m will be the mass of an object 1 and the capital M is the mass of an object 2. Okay, so don't worry about that also. They will sometimes denote with that. Okay. So now what we are going to do, we are going to find out the actual value regarding this both law of the gravity. Okay, see, here is a thing that we have to understand first, that the acceleration that we are understanding, okay, the thing that we have already discussed in the previous lecture, but we'll have to highlight that and we'll have to understand that again. Now the thing is the acceleration. The mass concept regarding the concept of mass regarding the free fall that we have already understood, but the concept regarding the acceleration that we are going to conclude in this lecture is what? The acceleration is basically dependent on which factor? As you can see here, a 50 kilogram of mass is experiencing a more acceleration than the 5 kilogram of mass. Why this happened to this object? Because of a thing called the gravity. Yes, you are absolutely right. Now whatever the acceleration is felt by these two objects, it is only and only because of the gravity. Okay, the acceleration is experienced by the gravity. So whenever a mass is more, the acceleration is applied on that object is more. Why? Because of the gravitational force. Okay, so that is the reason that we can replace the acceleration with an small g. Small g is the reference of the gravity. Okay, we have replaced the acceleration with the small g. Why? Because of the free fall the free fall that is applying on the object, it is only and only dependent on the gravity and the mass of the object. So mass we have taken m. Okay, whenever we are just considering on one object, then we have to take a mass of that object, and the acceleration is applying on that object. It is only because of the gravity. So that's why we have replaced the acceleration with the gravity small g. So from that equation, another I will change the color so that you can understand it. Now I will take a pink color. Okay. Now I will take this equation number 1 and I will take this second equation. We'll compare this both the equation and find out the actual value. Okay, the first and the second equation, I will compare this both the equation with each other, and then I will find out the actual value of g. Okay, but in the reference of g means a gravity's universal constant's value, or we can say that the gravity's value. How can we take the value of gravity? But when the comparison we are going to do is based on the two objects. Whenever we are doing a thing, then we'll have to take a two objects. So that two objects, whatever we are taking, is the two objects is one is the earth and another is the suppose we are taking and gravity into the reference of an object. So we take earth and objects with the comparison of that. Okay, we'll take one object as earth and one other object is suppose apple or ball or whatever the thing that we are going to assume. We are going to take that, and another thing that we are doing is an earth. Okay, we'll compare the both. So we'll have to take a mass of the earth and another mass is the object, whatever the object we are taking. Okay. So let's begin our today's topic, but that is the revision that we have to do, and you will have to memorize. I will give you a few seconds of time so that you can see this thing. Okay. Okay, so let's begin our today's topic, and that is very much important topic. Now these are the things that we have already finished in the previous lecture. Also, this is also we have finished in the previous lecture. Free fall that we have already finished in the previous lecture. Now, okay, here is the thing that we are studying. Okay. So the point is here, acceleration due to the gravity. Okay. Acceleration due to the gravity. Basically, it is also we have studied in the previous lecture, but in today's lecture, what we are going to do? We are going to take acceleration due to the gravity is defined as the uniform acceleration produced in a freely falling body due to the gravitational force of the earth. Whenever in some objects is making an effort to touch the surface of the earth. Why? Because of the gravitational force of the earth. Okay, so whenever we are throw the object, what automatically happen? It will automatically comes back to the earth because our earth's gravitational force. So it is acting the force. It is called as a gravity. Okay, now, and what happened during an object is come back to the earth, surface of the earth? It will eventually experience and much more acceleration in that. So that's we are going to study. See, here is the first thing that they have already given, that what we are going to prove is acceleration due to the gravity is 9.8 meter per second square. But how this value come? How? So because they have already scientifically proven that the gravity's value, that whenever an object is come to the surface of the earth, is experiencing an acceleration on that object because of the gravitational force of the earth. So why this object is experiencing, and whatever the acceleration the object is experiencing due to this gravitational force, is the value is considered to be a 9.8 meter per second square, because we have seen that meter per second square is the unit of acceleration. So the acceleration feel by the gravitational force of the earth is considered as a gravity. Okay, or we can say that the acceleration due to the gravity. Okay, so now into the deep that we are going, that we'll have to prove this value 9.8 meter per second square, how this value is come from. So for that we are doing a calculation, that why and how this value is came from. Okay, so first thing, suppose a body of mass m is placed on the earth of mass capital M and radius r. Okay, see, here is the thing, that suppose, for example, they have given us the point that suppose a body of mass m is placed on the earth. Now what is the mass of a body? That is small m. Okay, I have already told you in the starting of that lecture that when we putting an object, it has a mass of small m. Okay, then is placed on the earth of the mass capital M. Now what is the mass of the earth? So earth mass is basically capital M. Okay, see, I have already told you the object's mass is small m, while the earth mass is capital M. Okay, now you understand that. And radius r. Now radius means distance. If we take a circle, then here is the center point and here is the object's point. Okay, so in between them, whatever the radius is considered to be the distance also. Okay, it is also the distance between them. So we can say that this is a distance, or we can say that this is a r. I already told you that sometimes they will consider the distance as a r, sometimes they will consider the distance as a d, sometimes you can consider the distance as any alphabet. Whatever the alphabet you want to take, you can take it. Okay, but the distance is, in this topic they have, the distance is signified us by the r. Okay, radius r. So all three things that we have seen in the first law, okay, or in the universal law of gravitation, we're going to put these three values. Okay, so here comes the equation that we have already finished. Okay, I think you cannot see. I will change the color. Okay, here is the equation that we have already seen. We have taken the m1 and m2. Now what we will have to do, m1 is the object, mass of the object 1, so we'll have to take the object is a small m, so we'll have to take m, and m2 is the mass of an object 2. We have taken the object 2 as a earth, so what is the earth's mass is capital M. So this is the significant value of that capital M into small m upon d square. Now d square is replaced with the r square, so that is nothing new in this topic. Okay, now I hope you all understanding. They have replaced the proportional sign with the is equal to. We have given denotation of g because of that. Okay, now what we are going to do, we are going to do the comparison of the two laws. Okay, I will explain you first and then we are going to this topic. Okay. Here is a blank space, so I will explain you first here and then we are going to that topic. Okay, now we have already seen F is equal to M A. We have replaced M into G. Okay, and then we have seen F is equal to G into capital M small m upon R square. Okay, we are going to comparison these two laws. Okay, so m g is equal to capital G, capital M, small m, and r square. Now as you can see that this m going to cut. Okay. Now what we are going to do, we'll have to take small g is equal to capital G into m upon r square. Now we are going to put the value of universal gravitational constant. Then we are going to put the value of, see here is the capital M. So what is the capital M? Capital M is the mass of the earth. Okay, again I will show you, so that's why you cannot forget. Okay, see here is the capital M is the mass of the earth. Okay, so you have to remember that. Okay. Okay, so we'll have to take the value of that mass of the earth. Okay, and then the radius of the earth. Putting all the values of that, we can find out the value of small g, the gravity due to the acceleration. Acceleration due to the gravity. We can find it out that. Okay, now let us take that topic into the discussion. Here is. See, from the two equations we have, mg is equal to capital G mm upon r square. Mm is going to cut, g is equal to gm upon r square. So here is the equation that we have already derived. Now we are going to put all the values of that. The capital G means the gravitational constant value is 6.67. They have already scientifically proven the gravitational universe constant's value. So we'll just have to memorize that, and we'll have to just put the value of that. Okay. Here is the value. I hope all of you can see the value. Otherwise, I have written here because of the brightness. Sometimes it goes awkward. See the 6.67 into 10 raised to minus 11 Newton meter square upon kilogram square. Okay, this is the value of capital G. We are going to put that here. Then the mass of the earth is 6 into 10 raised to 24. We are going to put down that here. And 6.4 into 10 raised to 6. And also we are going to do the square of that. So we'll have to write like this: 6.4 into 10 raised to 6 whole square. So putting the all values in this equation and this three equations value in this, we can find it out that the G's value is 9.8 meter per second and square. And then that is the value that we can conclude it as the acceleration due to the gravity. So you just have to memorize the two things, that the second law of motion and the universal constant of the gravitation. That the both law you can, if you learn that both law, this topic is very much easy for you, because just you will have to just compare that both law with each other. Whatever the same amount of value, you can cut it down from the equation, like the small m going to cut, and then just have to put in the value. It will give us the calculation regarding the acceleration due to the gravity, and the amount that is come is the 9.8 meter per second square. Okay, so that is the topic that we have discussed. Now from this topic we have understand that we can replace the equations of motion with the G whenever we are considering the equation of motion under the influence of G. We have already learned the three equation of motion is written already here, but I am still going to write that so you can understand it. V is equal to U plus AT. Okay, then another law is S is equal to UT plus 1/2 AT square. Okay, then the third law is V square is equal to U square plus 2AS. See, these are the three equations that we have already learned. Now what we are going to do, we have already know that the acceleration can be replaced by the gravity. Whenever we are considering the motion regarding the gravity, then we can replace the acceleration with the small g. So we have removed the a with the g. See, here is nothing else. Now if you can see the equation, here is the written s and they have written the h over here. Why? Because the s is represent the distance. What s is represent? S is represent the distance or the displacement. Okay, so that is the thing. In the whenever we are putting an object on the surface of the earth, the distance is always as the height, okay, or radius or whatever the thing. Basically, if we take an object here and we have earth here, so whatever the amount is the height. So that is why they have taken the distance as h. Nothing new going on in this. Okay. So I will give you a moment of time so that you can understand this equation. Take a screenshot of that, and we'll finish our today's topic. Okay. So in today's topic, you'll have to write. I will give you the homework. Okay. So today's homework is question 1. Derive the value of G. Question number 2. Derive the equation for universal law of gravitational constant. Okay, so that's it for today. Thank you very much for hearing this lecture. If you had any kind of doubt, you can ask me on the comment section. See, we are making so much effort to making a lecture that you liked it or that you liking. So please if you like this lecture, please like the press button on the YouTube channel. Okay, and take care of yourself. Stay safe, stay home, wear mask and sanitize your hand. We will meet very soon in the school. Okay, so till then, bye bye everyone, and take care of yourself.